ERC office hours, nobody's coming to because I don't think anybody wants to go all the way across campus or people don't know where they're at. But the office hours of 4307, it's very, what's up?
The 119 that's on the syllabus, ERC 119, it's a boiler room.
It's 117 apparently.
Yeah, I think the Ritzky's, the number's wrong with Gilbert.
Yeah, we kind of figured that out this week. Yeah, 117. Apparently nobody goes to them, so if you want some very personalized help, there you go. Nobody goes to those, and the 4307 office hours are a little more popular since they're a little more conveniently placed. That's where mine are at, if you want to know. I'm there on Tuesdays from 10 to 4 at 4307. But office hours will be, from here on out, the most helpful resource you can find. Probably better than Piazza, because the big thing with Piazza is you can't post your code on Piazza, so please don't do that, because it's kind of cheating. And the trick is, when these homeworks get a little more complicated, and really homework is the way you learn in this class, is that if you want help getting your code debugged, which is going to happen, you need to go to office hours, because one, you can't really post your code in Piazza, so you can't really get help with fixing little errors. And two, if you try to email your code to the ECE 15, one, you're gonna get a crappy turnaround time, and two, we can't just tell you the answer to it's better for us to kind of help you figure out what's wrong with your program than for us to just kind of tell you straight up what's wrong with it. Just you'll learn better that way. So office hours, come to office hours. Lots of office hours. Okay. That being said, so for those of you who haven't finished homework 3, here's a few hints, and I guess since I had my office hours yesterday, I have a few more things since I wrote this up. I've seen people kind of having a hard time with. So some of you probably have had problems with trying to scan in a character. Use scanf to scan a character in, and for some reason you keep skipping over your scanf. Your scanf procedure, your scanf call, it keeps just glazing over. It looks like it scans in nothing. A few of you, yes? Okay. So does anybody understand why that is? Yeah?
Because for the code that we have to do for homework, you enter a number, and then you hit the enter key, and the enter key is in there in the buffer somewhere. So when you go to scan it, since the enter is a character, you go to scan a character, it scans that inner character.
So for those of you who couldn't hear that, I'll just kind of show you. So in your homework earlier, you're supposed to scan in a double or something, or whatever. Something like that, right? And then later on, you're trying to scan in a character that's like a yes or a no character. If you want to describe it, you want to treat it as an integer or not, or something like that, right? Whatever. I know it's a pseudocode, it's not correct or anything, but what happens, like he said, is that when you type things into the keyboard, it kind of puts it into this kind of buffer somewhere, and scanf pulls from that buffer. So this is what happens. You're typing in this stuff for this first scanf line, you're like 3,3, enter. This is what 3,3, enter goes into the keyboard buffer. Scanf says, okay, 3, good, comma, good, 3, good, and then it just leaves that return as a new line character in the buffer. So when you go to scan in your character the next time, that new line is still sitting there, and instead of grabbing the Y or the N that you press in, it grabs the new line character. Basically, the return press that you hit isn't getting picked up by scanf. You could do something like this, and it would scan in your return press, but it's not very robust. It's not a very robust way of dealing with this problem. A better way of dealing with this problem, like I kind of say here, is whenever you're going to scan in a character and you're kind of unsure, maybe you're doing things in your program before, you're unsure, you just kind of want to make sure that it doesn't do this type of behavior. A nice thing to put in is this nice little line. So if you guys have done a little bit with loops, you should kind of recognize that a while loop will keep going while whatever's inside these parentheses is true, correct? So this line is literally saying while get character, get char. So get char is not equal to new line. So this is gonna scan in. This is gonna scan in any new line characters and clear them out of the buffer. Basically, it's just gonna scan in any new line characters that are sitting at the front of the buffer. So that, assuming you don't want to scan in those new line characters that might be stray new line characters kind of sitting there, this is a good way to scan them in and kind of dump them before you scan in your your Y or your N or some other character. Is everyone on board with that?
He explained in class about 20 minutes ago that if you just put a space in front of the %C for the second scanf, that would do the same thing.
It'll do the same thing. That's fine. This is my problem with doing things like doing this or doing something like this or doing something like this. My problem is I don't like doing this because it's not quite robust. I'm not sure. Putting a space in is fine because scanf will dump spaces, right? Like scanf will ignore spaces. You can put spaces in scanf and it'll just kind of ignore them. I like doing this because it's a little bit more literal. I mean, a little bit more very definite, straightforward. And I don't know how different systems react when you're doing it in user input, like you actually hitting enter, versus us feeding things in like through the input text files and stuff with like the test cases. They probably both work. I like this because it's much more clear what you're doing. Do whatever you want. The space thing's probably actually a little more efficient and it'll work, but I like this because you know exactly what it's doing. But anyways, if you guys are having that problem with scanf, that is why, and these are ways to deal with it.
So it just loops it once and says.
No, it keeps looping. If you have like 10,
Yeah.
it'll like clear out any new line characters that are sitting at the front of the buffer until you get to a non-new line character. Anyways. Scan.
What only ends up in there when they hit enter to enter their input that first time, right? So there should only be one, right?
Yeah, it should only be one. Right, it's like I said, it's basically from not doing this like this. Basically, it's not accounting for that enter press and stuff like that.
So is that grabbing the character or is it grabbing the new line?
It's grabbing a character as long as the character it's grabbing is a new line. It's grabbing any new line characters that are sitting in the keyboard buffer, kind of at the front of it, until it gets to something that's not a new line.
So why isn't it not equal to new line? Why is it not equal new line? Character new line. I guess I'm not understanding the logic.
Backwards is what it should be.
For me, that's how I'm
So
reading it.
what is get char? I'll think about that for a second. Yeah, you think it'd be the other way around, but it's not. Nonetheless, let me get back to you on that. But yeah, you think it'd be the other way around, but that's the way it is. Anyways, if you have that problem, that's kind of a hint to get around it. Moving on.
Could you write it differently? Like if it is a space, then move on, tell it to do that. I get that.
It's not a space really.
Well,
Yeah, I mean you could do this. I don't know. Whatever. There's a bunch of things you can do. The line that I gave you will work though. Don't worry about it too much right now. Moving on. Things I've seen in labs that in the office hours people are having problems with. The modulo operator. Do people get that? How many people don't get modulo, what it is? Okay. So, in your homework, you're doing something like dividing, you get a big number of seconds, and a number of seconds and you're dividing into hours and years, and blah, 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 blah. So there's a bunch of different ways you can do this. There's like some very clever ways that are like, don't take very many lines. There's some ways that use if statements. All are fine. it's like maybe the first problem where you have to think a little bit of an algorithm, the way to do things. I'll say this, when you're approaching a problem, you're like, how the hell do I do this? A good way to start trying to figure out a way to do it is think, if I had to do this on paper, how would I do it? For instance, let's break that problem down quick and say we're only doing hours and minutes, and seconds, okay? So let's forget about the other stuff. If I gave you 8,000 seconds, and I said break it up into hours, days, or hours, minutes, and seconds, the way I would do it personally, I would think, okay, 8,000. Now, 8,000 seconds. If I divide that by 3,600, how many seconds do I? How many do I get? That's how many hours I get. Okay. And if I truncate that, that's how many hours it is. So that's 2 hours and some change. I say, okay, I have 2 hours. So let's subtract 2 hours worth of seconds from that. So 8,000 minus 2 times 3,600, and then I repeat the same thing. So that's one way of doing it. Another clever way of doing it, modulo operator to help you out. So the modulo operator is not too complicated. It literally will give you the remainder of a division. Okay? So if I have 7,200 modulo, or I should say 8,000, by 8,000 seconds, modulo the number of seconds in an hour, 3,600. It's gonna give me how many seconds are left remainder, right? So it's gonna give me 800. It's gonna be 8,000 divided by 3,600 is gonna be 2, and then a remainder of 800 seconds. So as a bonus, to those of you who are still quite lost in that homework problem, let's say we start with the number of seconds. It's equal to 8,000. And we said, okay, number of hours is probably going to be equal to, number of seconds divided by seconds in an hour. Okay? If you're using all integers here, what's going to happen? You're going to get 8,000 divided by 3,600, and it's going to typecast it to an integer, so it's going to truncate anything at the end of this. So if these are all integers, it's going to truncate this, and it's going to be equal to 2, right? It's not going to be 2 point something like it normally would. It's going to truncate it down to 2. Like, okay, great, I have the number of hours, but now I need to figure out how many seconds I have left. Well, I just told you. Now the number of seconds left, after hours, after you subtract hours, it's going to be equal to your original number of seconds. You can say your original number of seconds either minus your number of hours times, seconds in an hour, or you could say modulo seconds in an hour, because this is going to give the remainder from this original division. Is everyone on board with that? So all the modulo is giving you the remainder of a division. And all of you that are copying down this code to fix your problem, you have to understand what the modulo operator does, okay? Yes, you can take this code and you can format it so it exactly does what you want it to do, but it's better off that you actually you actually understand what the modulo is doing, operator's doing. Okay? Everybody on board with that now? Oh, what's up?
Numsec modulo seconds per hour.
Okay. So this is just the remainder of number of seconds. So that's like the total number of seconds we input, right? So 8,000 seconds
Yeah.
divided by how many seconds are in an hour. So that's going to be equal to 800 seconds. So it's just the remainder of seconds of seconds left after we divide it by the number of seconds in an hour. So if we divide number of seconds, 8,000 divided by seconds in an hour, 3,600, we're going to get 2, and then a remainder of 800 seconds. So then we have 800 seconds we want to divide up into how many minutes and seconds we have.
We haven't defined what seconds per hour though is.
3600. I mean, this is just pseudocode.
Oh, okay.
Sorry. I mean, I'm just describing. Yeah.
Okay, okay.
Yeah, just 3600 seconds per hour. So this is just
So
pseudocode.
we're just doing the division and then giving you the remainder.
Yeah, module
Two
operator
operators.
module operator is a nice thing to give the remainder of a division. So if you get really tricky, you can do stuff like, you know, instead of doing all this stuff, maybe you could later on you could do a line that was like, you know, number of minutes is equal to, you know, number of seconds modulo seconds in an hour and I'm not going to define that as 60. Anyways, so you get kind of what I'm getting at here, like clever use of modulo. It's like, okay, this is the number of, this here inside this bracket is the number of is that remainder of 800 seconds that we want to divide up into minutes and seconds. That's 800 seconds, so this is going to be divided by 60. So that's going to give you, it's going to give you what, 13 minutes.
There's no way to really combine the two functions into one line, no way. You gotta divide it and then you gotta do modulo, right? It's two different numbers.
What do you mean?
You divide it to get your number of minutes or hours or whatever, and then you gotta do modulo to get your remainder to work with.
No, I mean, you can kind of, you can do everything in one line, basically. For each one. And you can repeat and just make it longer, and I don't want to do the whole homework problem. So this here is the number of hours, right? We already established that.
Yeah.
This is the number of seconds left after this division. So this is the number of seconds you want to divide up into minutes and seconds.
Yeah.
So this is the 800 seconds, and you're going to divide it by 60, so you're going to get 13 minutes. But it's still going to have, you're still going to have 20 seconds or something you want to divide up. Or, sorry, yeah, 20 seconds you're going to want to divide up. So you can do something similar for seconds that I'm not going to type out. This is one way to do it that's like a little bit clever and complicated. If it's easier for you guys to do it, like say like, oh, if I have more seconds than there is in a year, I want to divide by that and then, you know, do this or that. You know, there's a bunch of different ways. This is like I said, this is like the first problem we've given you where it takes a little bit of thought and figuring out your own way algorithm to do it. So
I was able to do this problem, like for the most part, and get the correct answer, but my problem was getting huge numbers of seconds.
all right, yes. Next point I'm going to cover. So say you get your problem working just like this guy, and it's all working, and then you put in like 10 million seconds in, and then for some reason it stops working, and you get all these crazy numbers, and you're not sure what's going on. So 10 million is a big number, wouldn't you say? And our integers can only hold, our regular integer variables can only hold a certain amount. So what should we do? Long integer. And if that's not working, long integer. Now remember, when you scan those in and you print them out, you need to use a different specifier. Instead of using %d or %i, but I prefer %d, you need to use something like %ld, long digit, so that's a long integer, or %lld, or I. Okay? So you guys will run into that problem. You need to use bigger data types.
So if we used like a long int alongside, for example,
An int?
unsigned int, and then that should cover anything up to, as the homework says, 10,000 years. Because, I mean, I could have like a bug in the program, but I feel like I tried that, and it still gave me problems.
This is what I'll say. You have to be careful. You might think, okay, the only big number I'm dealing with is the total number of seconds. However, you have to be careful you have to be careful when doing calculations with different data types. So the first thing you're gonna probably do, you're going to use your first number of seconds that the user inputs. You're gonna probably say, I'm gonna use that as a long integer, so that I have no problem storing whatever number they throw at me. But oh, my number of years is never gonna go that big. It's gonna be 10,000, so I don't need that to be so huge. The problem is you gotta be careful because you start doing stuff like this, you have a bunch of different data types, and it's probably gonna use integers instead of long integers. So you might have to start doing. It might be a better idea if you're doing a bunch of calculations with different data types to just use long ints for everything. Does that make sense? Because you guys know now from like last week, like when you're doing calculations with doubles and ints, things don't always go in the same thing. Things don't go always exactly how you'd expect. So sometimes it's better just to make sure you're using the same data types so you get the expected output. Okay? And let's see, anything else I have in here? Scanf formatting, you guys should know better than that, better by now. How if you have like scanf, if you have spaces in your scanf statement, it can ignore things if you have spaces in your scanf but you don't have them in your input. Scanf is pretty good about just ignoring things, ignoring white space or non-white space. But it's better to have spaces in your scanf than not. It can ignore them. It can ignore spaces in your scanf if it's in your function versus if it's not what you type in, but not so well the other way around. Typecasting, you guys should know better. Typecasting will truncate. You should know that. That's actually why this works so nicely. And I'll make another plug for using the test scripts. Use test3.sh. Your grade depends on it. So now you guys should have had a little bit of work, a little bit of practice with the test scripts from homework 2. These things will be your guide to getting 100% on your homeworks. Yes, it checks character to character. You can sit there and say like, it looks like my things match, but it's giving me a diff file and they look the same. What's the deal here? You're probably missing a new line character or a space or a period or something. Make them match, because that's how we're going to grade it. I will say the way that we grade, we've set it up, we've actually finally got our grading stuff done yesterday, and the way we set it up is a little more lenient, but just make them match the test scripts and you'll be happy. All right? Now, I'm not saying that there's not any other test cases we can throw at your homeworks, but make them match the test cases and overall you'll be sitting pretty good. So please use the test scripts. Okay. Like I said, homework 1, 2 grades, they should be coming soonish. If you turn in homework 1, you're gonna get probably 100%. Homework 2, we're gonna be a little more lenient on with test script things, I think. We'll see how heavy the hand grading is. We've got some very interesting things we're implementing with the grading schemes. It's pretty neat what Daniel implemented. So we'll see how it works. But homework grades should be coming soonish.
With comments in our code, how precise should we get?
All right. Glad you brought that up. Comments. So, if you had me in office hours yesterday and you didn't had some really messy code, I probably told you it looked awful and I didn't want to help you debug it because it's kind of like this. You guys, there's like a lot of you guys, and when I'm going through office hours, going from person to person, and I gotta look at everyone's code, and like you're like, oh, this is what's wrong with my code. I'm like, well, give me a second. I gotta see what you're actually trying to do. But if you don't comment and you don't use variable names that make sense, and like this, it makes it very hard to read your code. Commenting, honestly, I'll say this: if you could take anything from this class, knowing how to write a little bit of code and commenting your code are probably the two biggest things are gonna be useful to you later in life. So because of this, we've decided that we're going to try to do auditing audit each one of your guys' code once in the semester, and assign you a part of your grade based on how well you comment from here on out. Maybe not homework 3, but after homework 3. So yes, you're going to be graded on your comment. I'm going to put out a video tomorrow that shows a good way to comment. And if you do it that way, each time you'll be happier because your code will look pretty, and it'll be easy to read, and it'll be easy to debug, and you won't have me yelling at you during office hours to comment your code, and you'll get 100% of that part, I'm sure. So yeah, we're gonna grade on commenting, however verbose the commenting has to be. And like I said, I'm gonna put up a little video tomorrow with some commenting and stuff, on commenting and that type of stuff, but this is my speech I always give about commenting. Commenting your code, you should comment your code so that anyone that's never looked at your program and has no idea what it's going to do should be able to look through your comments, should be able to read the code with your comments, figure out what's going on in each part in the least amount of time possible. You don't want to have your comments so verbose that it takes them forever to read through and be like, well, whatever, I can just see what it's doing myself. But at the same time, you want it to be descriptive enough so that if you have some weird line like this, I'm not going to know what the hell that does looking at it unless I wrote it like 10 minutes ago. So you need to describe difficult parts, section up your code so it makes sense. Anyways, I'm going to put out a video. I think it'll be pretty good tomorrow, and I'll throw it up on TED and Piazza, and you guys should comment your code. However you like, but I'm just going to put up the way I do it, and I think it's a pretty decent way. So, yes.
Will there be like another bundle to send in our comments or something?
No, it's going to be in your code.
Oh, okay.
Yeah, so the comments are part of your C file,
Okay.
right? Should be in line with your code. You're like, dividing up seconds, follow. It's in line with your C code, and when you actually turn in your homework, you actually turn in your C code, not the compiled output or something. So we'll have that. So yeah, we're gonna randomly audit each of you guys at some time during the year.
Will our comments be graded?
We're gonna audit you randomly during the year, and it's basically, there's no perfect way to write comments. It's basically like, is this easy to read? Is it conveying the proper type of information? It's a qualitative thing. It's not quantitative. So we're not going to grade. I don't really know what you mean by that. We're not going to grade each homework. It's impossible. I don't want to read through every single person's homework every week. But we're going to randomly audit you. So you should do it. It takes so little time. You spend more time debugging your code than writing your code. A good programmer should take like 10% of their time writing code and 90% like thinking about it. So just write good comments. You'll thank yourself later in life when you get into this habit. Seriously. It's like probably the best thing you can do for yourself.
So what if is there a problem with writing the comments after you do the code?
Dude, you should do them while you're doing the code. That's kind of the point. You shouldn't be doing it just to like appease the graders. You should do it for yourself, really. It's like one of the few things in this class that's like pretty useful to do on your own. Like I don't ever use C programming unless I'm teaching this class, but you should comment your code because it's something like that's going to be very useful to you in life. If any of you guys think you're not going to be using programming languages to do 3/4 of your work when you graduate or whatever, it's probably a little bit, you're going to be. So just do it for your own good. All right, now that we spent half the time talking about homework, let's go into some stuff. I want to go over this first before we get to loops. So this last week, you guys should have learned if statements and switch statements a little bit, right? Yes?
Mm-hmm.
Yes. Okay, good. And it could have come in handy. It did come in handy during the homework. If statements are pretty simple, but useful. So a real kind of hand-wavy syntax here. So for if statements, it's literally like, well, it should be lowercase, but you say if you have some kind of condition, if whatever inside of these parentheses evaluates as true. Now remember, true can be any number that's not 0, and 0 is false. So if whatever's inside of these parentheses is true, it's going to do this stuff here, right? And if you use else if, it's like, if this is true, do this, or if this is not true, if this is true, this new condition is true, do this stuff. And at the end, it's like, well, if none of these are true, do this stuff, right? Pretty hand wavy, but That's basically generally how it works. There's lots of ways to set up if loops, if statements. You can have lots of if statements nested inside of each other. If you want to do like, oh, if this is true, then check if this is true. If that's true, check if this is true. You do many layers of if statements. And you can have lots of conditions inside of here, as long as it all kind of boils down to one thing. So let's pull up a little example that I did in the other discussion section, if I can. And let's look at this. Show a couple examples of this. Now, where did I put this? Such a weird password. Where did I do this? Which one is the oldest? October 14th. Whoops. Okay. So this is a. Does anyone have any questions on if statements before we go over this little short thing? No? Okay. Not too complicated. So this is a good. I don't like this commenting. We'll add some in just as we're going for fun. This is how I like to add commenting. I like to at the top. Maybe have your libraries at the top, whatever. If you really need to describe your libraries, that's cool, but this is a pretty default library. So maybe don't explain it, but I like to at the top put a little program description here of what your program does. So ask the user how they are taking a class, letter grade, pass. This is a really bad explanation, but I don't want to really spend any more time on it. Anyways, program description up here, maybe your name. If you're writing your own functions, I usually like to put a function definition, but this is the main function, so there's not really one isn't necessary. But if you had your own functions, usually write what your function does up here. Because the whole point of writing functions is that so they're modular, so you can use them over and over again, so it's really like good to actually say what your functions do at the top, so if somebody else is using it knows exactly like what your function inputs, what your function does, what it outputs. It's really good to put that at the top, but not too useful here. This is really not useful. I don't know. Variable declaration. Yes, we wrote C before, so we don't need to. Here's the thing. You don't want to write your comments to say exactly what the code does. Like, oh, this is a printf statement. You don't write that. You write what the section does. Usually, so something like describing what the variables are is useful, so that like later, like if somebody's like, oh, what is this variable? What is this weird variable? What is this storing? You can look back at the top and you can see, oh, this is what it is. So users answer on how they are taking class. And this is somewhat this is a named piece of code, or well-named variable, right? Users expected grade. Yeah, so use variable names that make sense. If I come to your code and I want to help you debug it, and you named every variable A through F, I'm gonna pound my head on the table a little bit before I try to help you, because it's just so damn hard to keep track of stuff like that. Name your variables something that makes sense. It doesn't have to be super long, but please. So input from the user on how they are taking class. See that? We just section up the code in a nice little thing. Throw up here. If they are taking it for letter grade. All right. So here is the use of pound define. So if you guys have heard me talk about this before, pound define you can think of as a kind of a find and replace type thing before your code compiles. So I don't want to take too much time, but before your code compiles, the compiler will replace anywhere it sees these letters with these letters. So you can get real, like I said, I think I did it in this class before, but you can get really clever with this and put all sorts of weird stuff in here. I could put this and it's going to replace letter with those letters. You can put like code snippets and whatever. But usually it's like really useful to put stuff up in the pound defines for things that you might want to change in your program that would not affect the functionality of the program. Like this isn't really a great use of pound define. But say you were writing a program that was a grading program, and it took in weights of the homework and the exams and stuff. It might be good to put the weights up here so that you could change the weights of the program without going into the program to change them. Like something you might want to change in your program without changing the functionality. Anyways. So they input 1, 2, or 3, a number, integer 1, 2, or 3, and it stores it. And then we check if their answer is equal to 1, which is letter. If they're taking for a letter grade, we say, your choice is letter grading. And then I ask them, what grade do you expect? I get rid of the new line character that is probably scanned in right here.